Power distribution system, also known as PDS, is responsible for distributing power among various subsystems, making sure that the net sum of the power being delivered to all the systems is within the bounds of the power limits for charge and discharge of the battery. So battery, if you look at the spec sheet of a cell or a battery pack, you'll be able to find quantities like what is the maximum discharge current, minimum discharge current, or minimum charge current, upper cutoff voltage, lower cutoff voltage, etc. Using these quantities, you can identify what is the power limitations for your battery pack. Limitations or power limits are a function of state of charge, temperature, typically for current, whereas for voltage, it's generally constant. For instance, in case of a LFP battery, the voltage limits might be 2 volts to 3.6 volts, whereas for NCM chemistry, it could be 2.5 to 4.2 volts. Current limits are a function of SOC and temperature. It might vary based on where you are in the map of So let's understand how battery power limits are being applied and how those are converted into the remaining power left for the e-machine. Starting from the left, let's assume at a given instance, as I mentioned, it's a function of SOC and temperature. So at a given instance for a given SOC and temperature, let's assume that the charging limit of the battery is minus 30 kilowatts, whereas the discharging limit, which is indicated with a positive convention here, indicates 80 kilowatt. And the auxiliary consumption is, let's say, 5 kilowatts. So when we are charging, battery is not a source, but it's a consumer. When we are charging the battery, for example, using regenerative braking, motor now acts as a power source, whereas battery acts as a consumer. The battery, along with the auxiliary loads, is a consumer. So the summation of both the powers can help you determine what is the net regenerative power limit or the charging limit, which can be sent to the motor. So we simply add up these two to get minus 35, and then just for safety consideration, we might have a safety factor of 1 kilowatt. So we end up getting minus 34 kilowatt. On the other hand, when we are discharging, battery now acts as a power source and auxiliary load along with motor acts as power consumers. So the net sum of power consumers should be within the battery limits. So in this case, we simply subtract 80 minus 5, which gives you 75, and then considering a safety factor of 1 kilowatt, we eventually get 74 kilowatts. These two powers, assuming there are no other accessory loads like HVAC loads, compressor loads, etc., these can be transferred directly, applying some upper bounds, which can be considered as a very high value, making sure charging limit is negative and discharging limit is positive. So these can be transferred to the remaining subsystems comprising of the traction motor, for instance. So eventually we end up getting minus 34 kilowatts of charging limit and the 74 kilowatts of discharging limit within which the motor can operate. So this is how a power distribution system works, and it is very important to be implemented. Make sure the system behaves as expected.